Hi everyone, let's go on with application control in application development. In this part, I'll use a case a little more complex than the previous one to realize the effect of pressing a button to light up the light, and then explain the concept of adding devices in our Ruff. To add devices, there are actually 5 steps. Step 1, add a device driver into the application. Step 2, query the device API, and this API will tell us how to control the hardware through calling it. Step 3, generate the device's layout, which can guide us to conduct wire connections. Step 4, write the application such as writing its business logic. And in this business logic, there are some callings of these APIs. Step 5, deploy and execute the entire application. First, let's create a clean Ruff application here. I've actually created it, and then we need to execute the command of wrap device add to add this driver. There are 2 important options in this command. First one is I actually means ID, followed by the device name in the application you'll give to it. Since we'll use a button here, we name its ID button. The second one is M actually means model, and is followed by the model of this device in the wrap registry. Now we may take this button from our application kit. Its model can be found in this diagram. It's CK002. Next, we execute this command. Wrap device add I button MCK002. It prompts us the Ruff device driver has several versions. Well, it's okay for us to directly download the latest version. Okay, download completed. Next, as we'll use this device, we must find its API at a certain place. And this API list may tell us how we can operate this device. 2 ways are available for querying this API. The first one is after we add this driver. At the bottommost, this location actually shows driver link. Well, okay. We just directly copy it and open this website in our browser. Here, we may see the reference information on its usage mode and its APIs. Well, as for the second way, we may make queries at the official website of Ruff Registry. As its model is CK002, we'll type in CK002. As we see, it actually represents a module of a button. Click and enter. Its corresponding driver is button GPIO. So just click button GPIO and view some usages and APIs of this driver. And then, let's generate a connection layout and guide us how to connect. Well, at this terminal, it has actually prompted us, that is, wrap layout visual. We just copy and execute it. And here comes an app server. In fact, we may see in the browser its layout of connection like this. And when we place our mouse on a device, it will tell us some details of specific connections of this device. We're actually using the DuPont wire in our development kit. Just follow the prompt on connections to connect corresponding DuPont wires. After they are connected, it's roughly like this. In fact, with 3 wires, one is VCC, one is GND, and the last one is GPIO. Connect this button with our development board. For connections, we may refer to this connection layout. After we well connect them, we turn it off by pressing Ctrl and C. Next, let's write the logic of this application. We aim to, when we press down this button, turn on this LED. And when I release this button, this LED will be turned off. Let's directly enter this app file. Since we've already found some reference documents for an API of this button, we may directly write according to it. We copy it and paste it into this application file. ID has been named button. So far, we've completed the writing of the entire program. Its logic is enter this: push callback. When the button is pressed down, the action to be executed with this callback is to light up the red LED and continue to respond to events. If the event of release comes, it enters release callback, of which the action is to turn off the red LED. Upon completion of writing, it's the same as that before, for we're now having our PC connected to our external network. So we need to do some network configurations to make it in the same network with development board like we did in our last lesson. It's necessary to configure the environment to connect our PC to the Wi-Fi hotspot emitted from the development board. Click it. After they're connected, we still execute the command wrap deploy s to deploy the entire application onto this development board for executing. As we see, here is its effect. Up till now, all knowledge points about adding devices have been talked about. Still, I'll assign you an exercise after class. Like we did before, together with the timer function, use the button module as we discussed in this lesson to make a blue LED flash after pressing a button. The rule of flashing is to flash and go off alternatively every half a second. Stop flashing when it is released. Here's a note: the ID of the blue LED is LED B. Since we've been using a red LED, LEDR, and which R is red, and here B is blue. So the ID of the blue LED is LED B. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much. Ruff, make IoT easier.